Hi, welcome. Welcome to another video on this AEC and ME series. So, in this particular video, we will see the problems on 555 timer based multi vibrators. Okay, now in this particular circuit diagram, it is asked to write the expression for on time and off time of this 555 timer, which is a astable multi vibrator, under different cases. So when I say cases, so there are two switches, SW1 and SW2. So here if you can see, the possible cases are, so in the first case both are open, that is both the switches are open. Of course we have the other three combinations where it is like, okay, open open, open close, close open, and close close. So this is the thing. So let us try to understand what is the effect of these switches when it is open or close on the on time and off time. So for that, let us consider this 555 timer astable multi vibrator circuit. I have written the circuit diagram. So it's necessary that all of us know what is the function of each of the pin of 555 timer. So this is the pin number and the pin functions are also written, and I have written the output waveform and also the voltage across this timing capacitor, how it looks. So this is the timing capacitor voltage, this is the output voltage, and we are, of course we know that this is the on time from here to here, and this is the off time, this is T off. Now of course from the very basics we can actually get the expression for the on time and off time. Now we know that the capacitor voltage will always swing from VTL to VTH during on time, from VTH to VTL during off time. So let us write the expression for the T on and T off in general. So using the fundamental capacitor voltage equation, voltage across capacitor equation. This is voltage across capacitor at any time is given by V final minus V final minus V initial into e power minus T by RC. This is a very general expression for the voltage across a capacitor having a capacitance of C and a charging or discharging resistance as R. This is the time. So now if I want to use this equation to find the on time, so for T is equal to T on, the voltage across capacitor, at T is equal to T on, that is at, of course if you consider this as 0th time for your T on, from here to here it is T on. By the time the capacitor reaches this point, the voltage here is VTH in general. So it is VTH. The voltage at the edge of the on time is VTH, that is the capacitor voltage. Now let us also know during this period at the starting of on time what is V initial. So that's what is V initial is nothing but voltage of the capacitor at T is equal to 0. When I say T is equal to 0, it is actually this time. This is T equal to 0 and this is T equal to 0 for on time. If this is on time, the beginning of the on time is this. So that initial voltage under steady state is equal to VTL. This is VTL. So this is VI, that is capacitor voltage at T is equal to 0 for on time is equal to VTL. Similarly, if you can find what is V final. So V final is defined as, it is the capacitor voltage with T tending to infinity. Suppose if you consider this charging capacitor during on time, if this T is allowed to go to infinity, can you see this capacitor will keep on charging and will it reach VCC? So now I can say, or I can write Vf is equal to what? Okay, what if T is equal to infinity, where it will reach? It will reach VCC. So which is the timing resistor that is involved in charging this capacitor. Okay, for this CT, so let us, now this has to go to VCC. So this is the charging path. So charging path of this capacitor is R1 plus R2. So what I'll do is, I will say simply this R during on time. Let me say it as R charge, which is in this specific case it is R1 plus R2. This is during charging. So what is the capacitor that is involved? So the capacitor, what you are talking is C is equal to CT. Now if you substitute these values onto this equation, as you already know, suppose if you say, so what is this VCT at T is equal to T on, is it not equal to what? VTH. I'm just substituting this here. So this is actually VTH. So what is VF? It is VCC minus, again VCC minus VTL e power minus, this T becomes T on by this R is RCH, or I can write it as R1 plus R2. So it is RCH in general, that is charging resistor, and it is CT. You can say this is the expression. Let me rewrite that. VTH is equal to VCC minus VTL e power minus T on by, okay, in place of RCH I can write it as R1 plus R2 into CT. Now of course you can rearrange all these terms and you can finally write this expression. Okay, let me just redo that. So shall I write it as VTH? Can I write it as minus VCC? This VCC comes onto this side. Is it equal to minus VCC minus VTL e power minus T on by R1 plus R2 into CT. Now I will just make this minus of VCC minus VTH. Is it not equal to minus of VCC minus VTL e power minus T on by R1 plus R2 CT? Is the expression. Now I can just simplify this. Okay, this minus will go off. Can I write e power minus T on by, okay, let me write it as R charge. So let us interchangeably write, okay, this R charge is actually R1 plus R2. Let me write it as R charging R1 plus R2. This is what is the case. Is this equal to VCC minus VTH by VCC minus VTL? Now since there is a negative sign, I can make this positive and I can make it reciprocal. I will write it as e power T on by R charge into CT is equal to VCC minus VTL by VCC minus VTH. This is, so now what is T on by R charge into CT? Is it not, okay, take ln on both sides. So ln of E is 1. So now what is this? ln of VCC minus VTL by VCC minus VTH. So what is T on? T on is equal to R charge. You can see it is R charge timing capacitor ln of VCC minus VTL by VCC minus VTH. This is the expression. So what is this RCH for this thing? For this circuit it is R1 plus R2 is RCH. R1 plus R2 is RCH. On the same lines, so I can just try this. For in this expression, that is in that what is that? So let us redo that also. Let me just do that. So for T off, if T is equal to T off, so suppose if you consider this as your T off time. So at t is equal to 0 for t off. Is this not equal to VTH? So now V initial voltage when you are finding the off time is equal to VTH. Let me just clarify it again. This is your off time. This is your off time. During off time, when t is 0, that is this is 0. At this time, what is the initial voltage? It is VTH. So that's why initial voltage for finding t off expression, initial voltage is VTH. What is the V final voltage? Suppose if it is allowed to discharge for infinite time, where it will go? It will go up to 0. So this V final is 0. So what is the voltage of your capacitor at t is equal to t off? See, when the capacitor is discharging, if it is allowed to go up to infinite time, it will be 0. Suppose at the end of t off time, how much is your VCT capacitor voltage? Is the capacitor voltage equal to VTL? So what is this voltage here? So this is VTL. So I can write VCT at t is equal to t off is actually VTL. So what is the expression we have? We have the expression VCT is equal to t off is equal to what? V final minus V initial e power minus t off by R discharge. So resistance associated in the discharge path, R discharge into CT. So coming to your circuit diagram, so this is your capacitor, this is your discharge pen. While discharging, it will flow through this only R2. So R discharge is actually R2. So this is very generally writing. This is very specifically for this circuit. This is CT. So let me substitute the values. Is this VTL is equal to 0 minus VTH e power minus t off by R2CT. This is R2CT. Now, can I rearrange this? Is it not VTL is equal to VTH e power minus t off by R discharge into CT? Now this is the expression. Let me write e power minus t off by R2 CT is equal to VTL by VTH. Correct? This is what I have. Now I can make this positive by making this reciprocal. E power t off by R2 CT is nothing but VTH by VTL. So can I now write, of course taking ln, is t off is equal to, what is this? R discharge CT ln of VTH by VTL. This is the expression. Now we know that VTL is always half of VTH. This is known in the internal circuit diagram. VTL, the lower threshold voltage of a 555 timer, is always half of VTH irrespective of the control voltage. Even if the control voltage is equal to 2/3 VCC, this is control voltage, that is at pin number 5. At pin number 5, if the control voltage, that is at this point, it can be, of course, it will be 2/3 VCC. In this case, if you are connecting external battery, it will be that external battery voltage. Now, if control voltage is 2/3 VCC, that is VTH is equal to 2/3 VCC. Then what is VTL? VTL is actually half of VTH, that is 2/3 VCC. So this will go, is it not 1/3 VCC? This is VTL. So VTL is 1/3 VCC. So what is the ratio of this? Can you see then what is VTH and VTL? So from this, do we know that this ratio VTH by VTL, this is when it is 2/3 VCC. If you are connecting some external voltage, then what is control voltage? It is V external. V external. This is equal to VTH. Then what is VTL? VTL is half of V external. Half of V external. So whether you use an external voltage or not use external voltage, the VTH is always twice of VTL. So can I write this irrespective of whatever the voltage? Is it not R discharge CT ln of 2 times VTL by VTL? Does this VTL go off? So is it R discharge CT ln of 2? This is the off time irrespective of the control voltage, whether the control voltage is 2/3 VCC, whether it is external voltage, whatever. So what is this T of now? So T of now, because ln of 2 is 0.69, shall I write it as 0.69? For this specific case, the discharge resistance is R2. I will write it as R2 into CT. So this is my off time. This is whatever the value of V, control voltage. So this is even if pin 5 is at 2/3 VCC, or you connect any external voltage. So this is the case. Whether you connect some external voltage or don't connect any voltage, it is always 0.69 R2 into CT. Fine. So now with this basic, let us try to understand if I have a diode, here, and then have a switch connected like this, and here also I have a switch and I have an external voltage. V external. So this we call it as W2. This is switch 1. So now let us see what happens. If both the switches are open, then what is R charge and what is control voltage, or what is VTH? Okay, let us try to understand these cases where we have. Okay, let me write it here. This is when SW1, this is SW2. Let me say simply R charge and VTH. Let me just see only these two. If these two are open, let me say this is open, this is open. If these two are open, then what is the charging resistance? This is open. So if the charging resistance is R1 plus R2, shall I write it as R1 plus R2? So what is VTH when this is open? Is it not 2/3 VCC? See now, if both the switches are open, when this is open, it has to flow through this. The capacitor has to charge through R1 plus R2 only. So that's why R charge is R1 plus R2. If this is open, then the voltage at pin number 5 is 2/3 VCC. So this VTH is actually the voltage at this point. So this is actually VTH. Now, if this is closed, if this is open, now what is the resistance that is there in the charging part? When you close this, will it actually go through this than this? Because now what we are assuming is the forward resistance of this is very, very negligible compared to R2 value. So this, let us assume that R2 is like 10K. So that's what is there in the, how much is given here. So R2 is 22K. So when it is 22K, it is very large compared to the on resistance of this diode. So that's what we are considering. So what is this resistance now? It's only R1. So it is R charge is only R1. How about this? When this is open, it is still 2/3 VCC. Now let us take this as open, this as closed. If you open this switch, then it is R charge is R1 plus R2. If you close this, what is control voltage? Control voltage is no more 2/3 VCC. It's actually V external voltage. Getting this? if I close this, whatever voltage that I have applied here, whatever the voltage, whether it is 2 volt, 4 volt, 1 volt, whatever, so that will be my VTH. So what is VTL? It's always half of VTH. Suppose if you close both of them, if I close this, if I close both the switches, if I close this, is it only charging resistance is only R1? This is R1. How about your control voltage when you close this? Is it not V external? V external. Suppose if you write what is R discharge, is it always R2, 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 R2? Because discharging path, this will be reverse bias, because current cannot go through this, whether it is closed or open. Current will never go through a reverse biased diode, because the resistance offered by that is too large compared to R2. It will certainly choose R2. So R discharge is always resistor R2. Correct? If you can see here in this T off, since the same capacitor is involved, since the same R2 is there, since this is also 0.69, T off is always 0.69 R2 CT in any case for that matter in this particular circuit, whether it is open, close, open, close, close, off time is always, so T off for this particular circuit, so T off is always 0.69 R2 CT irrespective of the switch position, irrespective of switch condition, whether it is open, close, whatever condition. Now because R discharge is always R2, this ratio is always half, because whether you have control voltage as 2/3 VCC or external voltage, this is always ln of 2. So T off will never change. Now does your T on change? Yes, it changes depending on the switch condition. So let us write in a table form. Let me write what is, okay, now what is the expression for your T on? So now, okay, let me write S1, S2, R charge, and then let me write what is this, let me write what is V external, V control, that is control voltage at pin 5, and what I have, so what I have is this one. Let me find T on expression, and T off though it's 0.69, so let me not write T off at all. So if it is open, is it R1 plus R2? Is it 2/3 VCC? So what is the expression? So I have this expression, this general expression. Can I have this expression here? This is R1 plus R2 into CT ln of VCC minus 2/3 VCC, VCC minus 1/3 VCC. Correct? So now, is it not R1 plus R2 into CT ln of VCC minus you have it as what? VTL. This is this expression. VCC minus VTL. Is it 1/3 VCC? So this is VCC minus 2/3 VCC. So what is this value now? This value becomes, suppose if you, now this is like, okay, 2/3 VCC by 1/3 VCC. 3 will go, you'll end up with ln of 2. So this is R1 plus R2 CT ln of 2, which is 0.69 R1 plus R2 into CT. So whenever this switch is open, whenever what is this open means? When control voltage is 2/3 VCC, it is 0.69. This is R1, R2, this is your charging. So this is charging resistor, this is CT. So now what is this again now? So this is now open, close. So is this again R1 plus R2? What is this control voltage? This control voltage is this external voltage. So now how much external voltage you are talking about? in the this one external voltage is given as 4. So let me take this as 4 volts. So this is now 4. So shall I now come here and then write it as 4 volts? Correct? This is 4. So since it is open, this is closed. So this is not 1/3 VCC. So what is the expression now? It is now, since it is open, since switch S1 is open means this is a charging path. The charging path is R1 plus R2. I will write it as R1 plus R2 CT ln of, is it 5 VCC minus what is 1, this is VTL actually. How much is VTL? VTL is half of this. So that is 2 by 5 minus 4. This is VTH, this is VTL. So whatever this is VTH, you can see that is 5 minus 2 by 5 minus 4, which is ln of 3. ln of 3 is 1.1. So is it not equal to R1 plus R2 into CT ln of 3, which is nothing but 1.1 R1 plus R2 into CT. Okay, this is the expression. Suppose if it is close, you know that when it is closed it is 1.1. So now when it is closed, is this 4 volt? When this is also closed, is it not simply R1? Because charging it is bypassing R2, so there is no R2 coming here. So what is the expression? So for this it is fine till this is okay. When you have this as close, so is this equal to, because of this 4 I should get this ln as 1.1. Because of this R1, this R charging will become simply R1. This is CT. So this is the expression for this. Suppose if you say this is closed, this is open. Is this R1, is this 2 by 3 VCC? We know that when it is 2 by 3 VCC, so what is this ln you will have? You will have it as ln of 2. So that will become 0.69. It is now 0.69. What is the charging resistance? It is R1, this is CT. This is the change that will happen if you close or open. If the control voltage is 4 volt, then it is 1.1. If the control voltage is 2 by 3, it is 0.69. This control voltage can be any voltage. It can be 2 also, it can be 2.5 also, it can be 3.8 also. So whatever is the voltage, I need to substitute here. So what is this here? This is in general, you know that this is actually ln of VCC. It's VCC minus VTL by VCC minus VTH. Whatever external voltage I'll connect, this is external voltage, this is half of external voltage. These are the expression for on time, off time, depending on the condition of the switches. So now let us go back and see what is okay, that's what we are writing the expression for all of them. So these are the expression for on and off time. So off time though it is 0.69 R2 CT, the expression is same whatever the condition of the switch, but the on time expression varies across these 4 equations depending on the switch condition, whether you are having external voltage or default 2/3 VCC, whether you have only one resistor in the charging path or whether you have 2 resistors, or whether you are bypassing one of the resistor. So whenever this closes, you are bypassing R2. There is no R2 here. You can see whenever this is closed, this is not, there is no R2. Whenever this is closed, then it is ln of 3. That is, so here it is 4, here it is 2. Here also you can see, whenever you are closing this is 1.1. It is because of ln of 5 minus 2 by 5 minus 4. I hope okay, this is clear to you all. Let us see the next thing. Determine the frequency duty cycle of all the 4 cases. Okay, let us find what is the frequency and duty cycle for all the cases. Okay, again let us write the expression T on, T off and all those stuff. Okay, let me write it. So where is, again write, okay, this is S1, okay, SW1, SW2, so this is what, okay, now let me write as SW2. So is this open, this is close, open. This is again close, close. Let me say this as open, close. Okay, all 4 different conventions. So T off is same. T off is 0.69 R2 CT, 0.69 R2 CT, 0.69 R2 CT, 0.69 R2 CT. So I can actually find out what is the value. So as per this, what are the values of R2? It is 2.22K. It is 22 exponential 3 into 0.2 exponential minus 6 into 0.69. So time is, so for all of them, the time is 3.036 millisecond. That's the time out you have. So this is the time for all of them. T off is same. Let us write what is T on. So T on expression, when both are open, it is 0.69 R1 plus R2 CT. Now here this is open, this is closed. When you're closing this, in the charging path you have, because this is open, you have 2/3 VCC as your VTH, so it is still 0.69. So since this is closed, I have it as R1 CT. So now then here, since both are closed, so this is R1, this is 1.1, this is CT. So this is open, this is closed. Now it is 1.1 R1 plus R2 CT. Okay, let us find how much is R1. I think R1 is 10K, R2 is 22K, CT is 0.2 microfarad. If I am not correct, if I am not wrong, it is 10K, 22K, so on. Let me find this now. 0.69 into 32 exponential 3 into 0.2 exponential minus 6. It's actually 4.416 millisecond. Next it is, so only R1 is there. If only R1 is there, then it is only 10K. So shall I make it only 10 here? So it is okay. Now let me write it as 1.38 millisecond. What is for this? Now it is 1.1. So it is 1.10. Okay, this is actually 2.2 millisecond. Now this is 1.1 into 32K. Let me make it 32. So is it not 7.04 millisecond? So let us write the frequency. So frequency and the duty cycle and duty cycle. So frequency is addition of the timing 1 over that. So is it actually, so let me write 3.036 exponential of minus 3 plus of 4.416 exponential minus 3 addition 1 over that. It's actually 134 hertz. Okay, I'm writing only the number. This is 134 hertz, and in the next case it is 3.036 exponential minus 3 plus 1.38 exponential minus 3. 1 over that is 226 hertz. Next it is again 2.2 exponential minus 3 plus 3.036 exponential minus 3. That inverse is 190 hertz. Next it is okay 7.04 exponential minus 3 plus 3.036 exponential minus 3. 1 over that is 99 hertz. 99 hertz. So this is the frequencies. You can find the duty cycle. So duty cycle happens to be 4.416 divided by 4.416 plus 3.0 036. So now you have a duty cycle of 59%. I'm writing only the decimal number, not the fraction. Next it is, you have this time is differing by this is 1.38, 1.380. This is now again 1.380. now it is 31%. You can see when you have a diode bypassing the resistor R2, since R2 is more, you have a duty cycle which is less than 50%. Next it is 2.20 is your on time. It is now 2.20. Next it's again 2.20. I can see it is 42%. Next it is 7.04. because off time remains same, I'm just editing the on time. It's 7.04. You can see now it is 69%. So this is how we can find for different condition what is off time constant, on time differs depending on whether you are bypassing or not the discharge resistor, and this is either 0.69 or 1.1 depending on whether you are having a control voltage as 4 volts or 230 VCC. 4 volts or 230 VCC. So here we are assuming VCC as equal to 5 volt. If VCC changes, then your this 1.1 will also change. Then next, what is the next condition? What is the maximum voltage levels of the timing capacitor in all 4 cases? Okay, that you can find out. So here you can we can write. So it was asked to find what is the maximum and minimum voltages of capacitor voltage when it is in different 4 cases. So I'm just trying to write what is VCT max. So VCT max, of course, min is always half of this max. So since this is open, the VTH is actually 2/3 of VCC, that is 3.33 volt. When this is open, this is actually 3.33 volt. When it is closed, since you are using external voltage, it is 4 volts. This is 4 volt. This is also 4 volts. If you are writing what is minimum, suppose let me just look at lack of space. If you write it as what is VCT minimum, VCT minimum, it will be 1.66, 1.66, 2 volt, 2 volt. This is half of this. 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 Because this is actually capacitor voltage will always spring from. Okay, this is your capacitor voltage VTH. This is your minimum capacitor voltage. This is either 2/3 VCC or 4. This is 1.66 or 2 volts. That's what is this. Next question is, okay, why the T off is same in all the cases? So why T off is same in all the cases, as we already explained. This is my T off expression. This is my T off expression. Since this is the ratio of VTH by VTL, ln of, since VTH is always twice of VTL irrespective of the control voltage, so this value will never change, will be always a ratio of 2. So since discharge, as long as discharge resistance remains same, the T off remains same irrespective of the control voltage at pin number 5. So those are the answers for all these questions. Of course, this is what is written here. So I have written, okay, when both are open, okay, when one is closed, other is open. So this is when S2 is open means, okay, you are not changing the control voltage, but you are changing the resistor. So this is what is there. We can verify. Okay, thank you so much. So we'll see in the next video another